Good morning and welcome to today's Quick Bite. My name is Madeline Holzer. I'm the Education Events Specialist here at Zahn. Today we have Kris Schermerhorn, CDT, owner of Northern Virginia Dental Lab for VHF. And our Quick Bite is the new era in millable removables. Please remember that at the end of our session, we will have time for Q&A. So we encourage you to utilize the questions tab in your toolbar. And without further ado, I'd like to present Kris Schermerhorn. Thank you for joining us.
Great, Madeline. Thanks a lot. Yeah, so what we're going to do today is these quick bites, I think, are kind of cool. You know, we don't always have so much time during the day, and so this gives us a little bit of information. It's tricky putting together a presentation and getting a good amount of information across in such a short period of time, but I like this. I think concentrating specifically on milling, not really on design and all the different things. So it really gets to the point, gets the information. You know, what we're going to talk about today are, you know, specifically milling. I've had a VHF machine for 5.5 years, so a lot of experience with it. It's a rock solid piece of equipment. And we're going to talk about how it relates to the removal side. Things have shifted. I mean, that machine and the strategies that it initially came with, surprisingly, were pretty fast, even so, when I first got it 5.5 years ago. But tooling development, strategy development has made it even faster to where we can compete with printing as far as the turnaround time of having a case completed. So we're going to talk about the consistency, right? Speed is great, but if you don't have something that's accurate as your end result, well, speed means nothing. So having consistency and reliability is really important in the equipment, and the technology behind the equipment is of course, has everything to do with it. And then we're going to talk about, you know, now that we have something we can produce fast, we produce it accurate, we're going to talk about the profitability of that and how you know, material costs relate to labor and some things like that. So the material specifically I'm going to talk about today, and it's because it's material I have the most experience with, is the VisiClear, Duraflex, and Duraseal. All right, so as we go along and I talk about these materials, VisiClear and Duraflex are essentially the same thing. Just one has a pink pigment and one is mostly clear. This is a very flexible material, and you know, kind of has its place in competing with Valplast type materials, TCS type materials. But a lot of people are doing frameworks out of them. You can also mill them with sockets, but you do have to rely on luting the teeth together, you know, into the sockets mechanically. So that can have some challenges, but people are really liking the framework concept. Acetal is a more rigid material. Still has flex, but is a little bit more rigid. And so I'm not really here to talk about these materials, but I want you to give you kind of some understanding of what you're going to see as you go through this. You're going to see these frameworks. And that's a lot of what I produce for my doctors, are framework with acrylic saddles. So just like a metal, just no metal. Has internal, external finish lines and meshwork, and you process acrylic and denture teeth to that. So just a little baseline of what you're going to be, you know, seeing here. All right, so to start out with, let's talk about the equipment. Whenever, you know, again, 5.5 years ago, when I was looking to spend that large amount of money on a mill, you know, I looked at a lot of the different mills in the industry, and one thing I really settled in on was I was going to produce a good bit. I still am going to do zirconia, and I have a full service lab, but I also knew I was going to do a lot of plastics, and I knew that the plastics were going to spend more time in that mill. And so I knew I needed a puck changer. You know, for an extra $10,000, $12,000 is about what the jump was from a standalone single puck mill to a puck changing mill. And I really, when I figured it out, I was like, this is going to keep me from having to buy a separate mill when I get to a certain amount in production. And that separate mill was going to cost, you know, $30,000 or around about 30 or 35,000. So I was like, the extra 10,000 now that can save me, you know, $20,000, $30,000 later. Well, that was my decision making and going with the puck changing mill. So I have the S2, and that's what I've been using for the last 5 years. The S5 is very much similar to that mill, but they've done a lot of cool upgrades to the piece of equipment itself. The general way the mill works is the same. The case looks the same except for different color and stuff. So we'll talk about some of the cool things that they've done that I wish I had with my mill. That's, you know, doesn't make a difference in the end result. It just makes a little bit of it, and you'll see kind of ease of use. So, you know, that is the big thing as far as being able to change those pucks in and out. You know, it can do a good bit of work while you're not even there, or it can do a good bit of work while you're at lunch or whatever it is. You don't have to worry about exchange. You don't have to worry about running a job. It stops. You get busy with other stuff. You realize an hour's passed since the job stopped, and you could have been milling for an extra hour. There's a lot of little things where it'll just bring the pucks in, mill them, bring them out, bring the next one in, bring it out. And once you load up a couple of projects to go, it's not, you know, you'll be surprised at the time that will save you. And so the ability to have the wet mill. So that's something that I haven't utilized, but it's something that can be added on to this mill, that I could add on to my mill, is being able to mill wet, be able to do Emax or a material like that, being able to do some metals, things like that. So as you know, lab grows and stuff, I could always convert that over, have the ability for it to mill wet, and really expand what I'm able to offer. So it is a nice thing that that it does have that ability to mill wet. I mean, it really changes that mill to be very much more versatile. Yeah, so the footprint of all these mills is kind of unbelievable. I have an old lava mill down in my basement that's almost 1,600 pounds, right? The footprint of this thing is, you know, I don't know, 5 foot by 3.5 foot or something crazy like that. And, you know, it's the technology of that mill is nothing compared to this mill that sits on a countertop that's probably 2.5 foot by 18 inches deep. You know, so it's amazing. You know, and that's with anything. I mean, we have our phones that, of course, I don't know what they say, the computing power is more than what they used to put the people on the moon. So everything's like that, but that is very true. Do not think because it's a tabletop mill that it is not a super accurate, you know, very precise piece of equipment. As I get into it more and more, I'm realizing the technology that's involved in this mill is pretty amazing. All right, so again, I've had mine for 5.5 years, but it's definitely a proven company and a proven mill. All their different mills are proven. And, you'll be really, really surprised when you do these how fast and accurate they are. So yeah, I was not a high production lab whenever I bought my puck changing mill, but you know, the big thing I thought of was just the fact that as you grow, and it wasn't even as you grow, but as you just do more and more of your appliances digitally, you know, there's more and more going to mill. Matter of fact, the other day I was thinking to myself, like, we're having some good months, you know, my lab is, and I'm like, why am I working so much? Like, you know, I think back to previous years and I'm like, you know, when we were hitting, you know, I guess, you know, similar numbers, I was like, I don't remember being so tired and working so much. And what it is things have shifted in my lab. You know, we're doing a lot in our employees have shifted because digital has taken over certain parts, and then other technicians have taken over other things. And you know, right now we're kind of the point like I need to hire someone because the digital is just taking up so much of my time in design and getting everything together. I mean, we're only a 5-person lab, so you know, I sit at the bench and do work every day. So you know, and I'm feeling it, which is a cool thing, right? Because digital is cleaner, it's more precise, more consistent, and so I like the way we're going. But you know, you don't have to get this you know, mill because you want high production. You want this mill because it allows you to do other things while it's just working. Again, with the idea of pulling the pucks in and out, and you're not having to worry about stopping what you're doing and go load another one. If you don't think that you can afford to get that puck changing mill, I mean, that, you know, $10,000 to $12,000 is a chunk of money. Don't get me wrong, you can get those regular mills and they will mill fine for you. And if you feel like you do have the time to move those in and out, it's a great option. So don't let me scare you away from a regular mill. But the puck wing changing mill is what I have experience with, and so I just wanted to share that with you. So again, you can mill acrylics, you can mill titanium. If you have the wet option for the titanium, you can mill, you know, lithium to silicate Emax type material. But really, to have the water cooling for lubrication and cooling addition, it's really for the lithium disilicates and the metals. Plastics, you don't have to have them, and mills just fine without them. So to hold 8 discs, right, so you could have 8 jobs set ready to go. I mean, in a lot of instances, that could go all night, maybe still be going when you get in the morning. Blocks, when it talks about blocks, you're talking about lithium disilicate base as a holder for individual little blocks, kind of like the blocks that doctors use in their mills in office. And then, of course, if you were to do the prefabbed, the interface has already been milled, FDA approved, and you're just milling the top. That's what we're talking about. We're talking about the prefabbed abutments. Yeah, you know, as far as the puck changer, you know, it's a piece of German engineering. I mean, everything is over-engineered, which is great because, you know, this mill, you know, kind of like Mercedes-Benz, you know, this car, a Mercedes-Benz car is going to go for years and years and years. It's kind of like this mill. I mean, you're investing in something that's going to go for a long time. Of course, you're going to have to replace and do regular maintenance on things, but man, you know, I think you drop this thing off a building and it probably still mill stuff. It's definitely well built. You know, the Ionizer is something I don't have in mine. And what that is it just takes away the static charge. It's really nice for plastics. It doesn't really hurt anything because the plastics build up a static electricity and they just cling to everything on the inside of the chamber is what that is. And all you have to do is run it over with a brush and they all kind of flop off and bring your section and clean everything. But it is nice to have that going so that the particles don't cling and they just drop into the bottom where they can easily be drawn in by the suction unit. All right, so that's my quick little spiel on the mill. You know, all I can say is I have one in my room. It's milling something as we speak, and it's been going for 5.5 years. I've gone regular maintenance and really nothing else. So it's rolling right along. That's my experience, and I've been very happy with it. So when I first got my mill, everything in our industry is kind of based off of Crenna Bridge when I first got it, right? So the strategies, the tooling, even the PMMA tooling that was offered was really the same kind of geometry as the zirconia tooling, just didn't have the diamond coating on it. So as digital got better and started setting things up for the removable side, these companies started to develop strategies. And for anyone who doesn't understand strategy is just the calculation of how fast the spindle turns, how big of a bite. So each drop and it does a surface and then drops again and does a surface. It's how far that bite is, you know, down into the material. And how fast it'll move, right? So it's all in the paths that it takes. So that's kind of what a strategy is. So they've developed strategies specific to the plastics as well as the tooling, right? So you can see here, this is what's called a single flute tool. It has one bite to it, right? If you were to look at your zirconia, or even a lot of the tools that you would use in your handpiece at your desk, they would have 2 flutes or 3 flutes. So you'd have a cutter, and a cutter, or just a cutter and a cutter. The thing with plastics is as one side's cutting, if the other's cutting, it can build up heat. And with plastics, that can be a problem, especially when you want to mill it as fast as possible. So with a one flute, it'll dig a chunk off and it busts, of course it's going hundreds, thousands of RPMs, but it's knocking chunks off as it goes around. You should see nice chunky pieces in the bottom of your mill. And so the single flute tooling allows for that to happen. So it allows for the strategies to be speeded up using those single flute tools. So VHF, has single flute tooling, a whole line, 2.5, 2, 1, and 0.8, 0.6, I can't remember, small one, single flutes to be able to mill those plastics quickly. And so the machine, the tooling, and the strategies all equals times. And so what I did is I did a screenshot of this, which is a list where I pull up in my CAM software of different projects I've done. And so you can see here, here's a upper. So the more surface area something has, that usually equates to a longer mill time. A smaller surface, like a lower, it just has less surface area, equates to a faster mill time. And you can kind of see that here, but you can kind of see how fast it is, right? This is an upper, it milled in just a little bit over an hour, all right? Here's a lower, milled in just a little bit under an hour. Here's where I fit 3 partials in 1 puck, which is relatively rare, right? So you aren't looking at, being able to fit 3 in all the time. You're looking at, maybe 10 or 15% of the time you can, partials that are small enough that you can fit in 3 of them. I would guess 10 to 15, maybe 20% of the time. Most of the time it's 2, but then you have some vacant space. You could do some small unilaterals or something like that. But you can see with 3 of them, it's 2 hours and 37 minutes, right? So now I will preface this. This is a beta test. This is the newest CAM software that will be released this year from VHF. So if anybody on here has a VHF and is using dental CAM earlier, this will be the newest update that will be coming out this year. They say it should be soon, in the next few months, but definitely this year. And they do have some strategies that have kicked up. Now, I will tell you this, before I got the beta and started working with it, this number here would be about an hour and a half, maybe an hour and 35 minutes. This one here been an hour and 20 minutes. So even with your strategies and the CAM software you have, it's still very fast. It's going to get faster. You can even see here, here's a crown I did, a zirconia crown, 20 minutes. That's even fast with the zirconia. I know we're here to talk about plastics, but really fast. Here's a little unilateral, milled in a half an hour, right? Another lower, hour, upper. We're all hanging at about an hour for a partial, a little bit over, a little bit under. Here's another little crown, 16 minutes. So everything is faster. It's the spindle. They have a very robust, strong spindle. And that really does equate to being able to mill things faster. And so it's really, these are really good examples of that. VHF does make their own tools, right? So it is nice that the company that makes the mill also produces tooling for the mill, because of course it's going to be dialed in specific to the mill. So they do have, diamonds for the lithium disilicates and materials like that, as well as the diamond coated for the zirconia, and then the single flutes we already talked about. So again, everything is dialed in for the material, the geometry of those flutes are so that it throws that material away and does the most efficient grinding. And again, their strategies are designed for their tooling. And so there's very specific things in those strategies to work with their tooling. So yeah, all in all, it makes it really important. And 3 millimeter shank means that you can have about a 2.5 millimeter actual cutting surface. So the bigger that cutting surface, the more material moves in that one swipe of the material. So that works out really, really well. So let's talk about efficiency, right? Fitting 3 into a puck, right? So these pucks, depending on the material you're deciding to do, but generally speaking, for the acetal, VisiClear, Duraflex, those materials, you're looking at about $70 to $75 for a puck. So you're looking at about $35 to $20, $22, depending on if you fit 2 or 3 into that puck, the material costs. Previously, if you injected, you were looking at probably between plasters and stones and everything, just the material, you're probably looking at about $12 in material costs, but you have all the labor. There's no duplication of models necessarily. There's no investing. There's no oiling out. There's no injecting. So definitely huge savings in labor in milling these. And again, that one that did 3, I think it took an hour, 2.5 hours, 2 hours and 45 minutes. So, you know, not long at all to have 3 partials ready to go to the doctor. Here's what it'll look like in your CAM software. You just want to support all these vacant areas so they all support each other, right? Support the tip of the clasps, very important. This is going to be flexible. We don't want it flexible while it's in the mill. We want it to be rock solid. So having those support pins at the tips and any areas that have flex to keep it rock solid, that's what's going to give you your accuracy. You don't have to have big support pins. 1.5 millimeter support pin is fine. Just have a good bit of them, and it's not going to slow down your milling. It won't really affect it at all. So just if you thought you'd put enough support pins, put a few more, is what I always say. Night guards, even a PMMA, you can mill these night guards out in 2 hours, 2 hours and 20 minutes, something like that. Again, no articulating. You could do it totally modelless if it's a digital file. So definitely a time savings there. And those material costs for PMMA, depending on your company, could be, anywhere from $15 to $35 for just a clear PMMA, I'm guessing out there. So material cost is probably pretty similar to like a suck down material, which are usually $4 to $5 a sheet. This would be, $10 material costs. But again, the duplication, being able to go modelless is nice, and being able to mill them out of just a regular acrylic. So let's say you have a case that is I want to fit 3. I milled these 2 earlier in the week, whatever it is, they're gone, and I want to stick another one in there, it'll fit. But I have all this space, right? And this is going to be a little precarious. This is going to move around. This is going to be problematic. Take some of the old acrylic you have laying around. All of us have some old acrylic that we don't use anymore. Mix it up and just fill those gaps, right? You can see this is the same case here. Here's the previous mill, right? I nested this. Here's this case. I just fill that up with some old acrylic, let it cure, and then I'll mill it out. And as it mills, if it hits any of the acrylic, it'll grind it fine. It's the same strategies and tooling. It'll just mill that away. But the support pins and different things will be supported by that acrylic that's existing there. So to help you be as efficient with your material uses, again, I'm not a salesman, I'm a technician. I'm going to try to save money where I can. And this is a really good way of doing that. Just a little tip. So once you mill, this is how it comes out. Even on the lowest setting of quality. So VHF in their CAM software has 1, 2, or 3 star quality milling. At 1 star, you're going to have it come out almost looking like it's polished, right? You can see here, you want to hit it with a little pumice, or a lot of these materials have their own little polishing kit. But it will take all of 30 seconds to kind of just give it get the very fine tooling marks off of there, get a good shine, and it's out the door. So finishing, previous when you would inject these, you had a good 15, 20 minutes, maybe 25 if you do polishing of labor involved. With these, you got 5 minutes. You trim these little buttons off, they trim easy, shape things up a little bit, drop it down on the model. I mean, they almost always drop right down. There's hardly ever a time I have to do any kind of adjustment, and then polish it up and you're ready to go. So definitely a labor savings when it comes to doing these frameworks. And if you can convert doctors that do metal frames over to these, keep it in-house and not have to outsource if you're outsourcing now, not only will you save money, but you'll become a profit maker. You could do unilaterals, all one piece. Tooth, clasp, everything is all one piece, all acetal. Acetal comes in all the beta shades as well. Well, not all in milling. It comes in bleaching, B1, A1, A2, A3, A3, 5, and then it has a C3, I think it is shade. probably get you covered for what you would need, but you can do all one unit. And it's nice to fit those in areas where you're, missing, you have a little space and a puck left. Here's the pink acetal. It blends in pretty well. It's not as translucent as some materials. It's just the nature of the material, but it'll blend in nicely compared to metal. You can do long-term temporaries. Right, the material is very strong, much stronger than PMMA. So it's a nice option, again, when you have those little vacant spaces, when you've milled 2 frames and you got just a little space here or there, and, do your temporaries out of this material, and you'll use that up. And it makes for a crazy strong, doesn't absorb moisture, very healthy option for patients, especially if they're gonna be using these long term. Again, unilateral one piece, your option is an acrylic flipper, right? When you rather have this, cost between the two is going to be similar for most labs. This can be, again, fit in just a small little area of a puck that's already been milled. Design's really quick. Probably something of this size will probably mill in 25 minutes, and not having to deal with all this going across the mouth, affecting speech, and really not staying in as much as we call them flippers for a reason, because these will latch in nicely. Snap-on smiles or cosmetic orthotics, right? Opening the bite. If you want some more information on the snap-on smile, Meyerson is the Shine. Zahn is kind of an exclusive provider of those. The training and the pucks that are used for those that you can mill in VHF. You can contact Zahn and they can get you more information on getting trained to do those. All right. So yeah, I think again, this is a quick bite of kind of really zip through things, but I think it's a good baseline for what you're doing. I've been doing plastics for many years. I moved my lab about 2 years ago, and when I was doing that, I had all these pucks. And I'm like, I'm a bit of a hoarder. I was like, oh, I could fit a crown in there. I could fit a little unilateral over there. I could fit a another bridge crown over here. So I keep these pucks, and I got them all, and I laid them out on the table, and I was like, holy mackerel, you don't realize how many of these things you mill until you have it laying out in front of you like that. So I thought that was a funny picture to end on. So, all right, great. So what they'll do now is she's going to check and see if there's any questions for me.
That's great, Kris. Thank you so much. And yeah, I do see some space on those pucks.
Drives me nuts. I can't throw them away.
Right. We did have 2 questions come through from Danny. Really quick question. So is there a special liquid for wet milling?
So the way that wet milling works, there's kind of a basin, and that material, that fluid's filtered. Again, I don't have it for mill, so it's not really something I know in depth, but definitely give VHF a call on that one. But I know that it's filtered, right? And I know that you would kind of use its own tank, so you would replace that. But beyond that, I don't think there's any special fluid that would be used. It might have a lubricant involved with it that you might add to it. But again, it's not my specialty. I haven't done that in all honesty. So I would contact VHF and they'd be a direct, more accurate answer on that.
Okay. And explain detail maintenance and cam upgrade included in the price of milling units.
Yeah, so the way that it works is funny. I just talked to them about it yesterday, so I made sure that I had, because I thought that question might get asked. But yes, so if you have like Dental Cam 7, I had Dental Cam 7 when I first came out. So as upgrades happened, every time you started the cam, it would actually search for updates and would actually update automatically. If it jumps to a different, like Dental Cam 8, when it jumped from Dental Cam 7 to Dental Cam 8, then you would have to purchase that upgrade, but it's relatively inexpensive, especially compared to a lot of other companies. So you could stay in Dental Cam 7. I did for many years because I was great. I didn't have a problem with it. When they started developing some of the single flue tooling and the strategies, that's when I was like, okay, I gotta move up. But I could have stayed back and milled great, and it was fine. So you could choose whether you want to upgrade again through the Dental Cam that you have through that initial number. You'll get free updates. Once it jumps to the next number, that's at a point to where there would be a fee, but it's not that much compared to a lot of companies. And I don't want to talk about pricing. I would definitely call VHF and find out exact pricing and what that might be.
Okay. And Jenny, if you have any additional questions, please don't hesitate to reach out to your Zahn representative. We'll get you the answers that you need. Right now, we do not have. Go ahead, Kris.
Oh, I was going to say he did ask about maintenance, and maintenance is
Yes.
really easy. You're going to calibrate it. You're going to do cullet maintenance, which is cleaning it, and periodically you'll change out like your tool holders or little rubber grommets. You'll replace those. There's touch offs in the machine that's a way more long-term maintenance. It's just where the machine goes through movements and touches and makes sure everything's in general working order before it starts milling. I've replaced those once, wasn't too big of a deal. And then the spindle, that's usually at 3,000 to 4,000 hours. And, you know, so that's, I mean, I haven't even changed my spindle yet, and it's been 5 years. So basic maintenance like you do on most anything, but do good maintenance. Do those cullet cleanings, keep it calibrated, and the machine will last long for you. That's a great question.
Great. Thank you so much, Kris. And we do encourage you all to please join us for our next Quick Bite with VHF on April 21st to increase lab profitability. We also have a webinar on the 22nd with VHF on streamlining your workflow. I'd like to thank you all for joining this Quick Bite today, and thanks again, Kris, for your expertise. And we will see you on the next Quick Bite.